Okay, so we are solving systems. What is a system? A system of equations is a group of two or more equations with the same unknown variables in them. Usually they use x and y. So guys, for example, this is what a system looks like. It's a pair of equations that are missing the exact same unknown values. The x in this equation represents the exact same x that's missing from that equation. It represents the same unknown value. This y and this y represent the same unknown number. So when you solve a system, you are looking for an x and a y value that makes both of these equations true. I have to find out what is the missing value from both of these equations, but it's the same values. So I'm trying to find an x and a y value that make both of these equations true at the exact same time, okay? Normally in math, if they're going to give you an equation that has two unknown values in it, that's an unsolvable equation. You can't solve an equation when two things are unknown. You have to have something to go off of. So what happens is, with a system, they give you the two equations to kind of work off of each other. You're going to put the two equations kind of together to come up with a collective answer, all right? So that's what we need to do. We have to find an x and a y value that make both of these equations true. So like I said, there's actually a few different ways to solve a system. The way that we teach you first, or basically review with you guys, is to solve it by graphing. And I get it. Graphing is usually everybody's. Do you need one?
Yeah, I was gonna print one, but with the remote so I can freeze it.
Oh yeah.
Sorry.
We're good?
I didn't interrupt you. Yeah.
Okay. So now graphing. I'm just gonna warn you. In the future, when we're solving systems and they don't tell you what method to use, I don't think any of you are gonna be like, oh, I'm gonna pick graphing. I'm gonna solve this system by graphing. Number one, a lot of you hate graphing. Number two is, what if the answer to the problem is when x is 364 and y is negative 182? Does anybody want to graph until you get to those x and y values? No. Another reason why graphing might not be the best pick in the future is, what if the solution to the system are fractions? Are a lot of you guys good at looking at a graph going, yeah, that looks like 2 and 1/7, and that looks like 4 and 5/9? That's very hard to do when you're looking at a graph. So graphing, it's a great way to start because it gives you a really good visual as to what you're doing when you're solving a system. But at the end of the day, graphing is just not practical to solve all systems by that method. So we have two other ways that we teach you how to solve a system. We're just not doing it today. They're in the next days to come. So the second way we teach you how to solve a system is by a method called substitution, if that rings a bell. The substitution method. And then the third way we teach you how to solve a system is the elimination method. And that usually ends up being students' favorite method. I don't know if any of those names ring a bell, but you should have seen them in Algebra 1. So again, today we're going to concentrate on solving a system by graphing. However, regardless of which way you choose to solve a system, when you solve a system, there's only three answers. There's only three types of answers that you could get when you solve a system. One answer is that you actually find an x and a y value. You find a point. So one answer that you're going to get today is 1 point. You're going to find an x and a y value that make the equations true. That's what we hope for. Okay. But guys, what if, because we are graphing, what if the two equations they give you end up being the equations of parallel lines? Do parallel lines ever meet? Do parallel lines have any x and y values in common? No. So if they end up giving you two equations of parallel lines, then your system is not going to have a solution. So the answer would be no solution. So you might get that in today's problems. And again, the reason you would get no solution is because they're parallel lines. They're never going to meet. They're not going to have any x and y values in common. Okay? And then the third type of answer. Guys, what if the equations they give you happen to be the equations of the exact same line, but in two different forms? Then, if they end up being the same line, they're going to have every single point in common, which is way too many for us to count. So in that case, you get so many answers to the system that you couldn't possibly list them all. So we call that infinitely many solutions. guys, that's a mouthful, so usually I just shorten that to IMS. And again, the reason you would get infinitely many solutions is because they end up being the exact same line. Okay? Okay. So today, we're going to concentrate on solving a system by graphing. So I'm going to show you the list of steps, and then we're going to solve a couple.
I unfroze it, so you're good.
Okay, thank you. Okay, guys, normally they make you label the systems once you solve them as consistent systems, independent systems, dependent systems, inconsistent systems. Please don't worry about the first two. It's really not that important, and especially since we're crunched for time, don't worry about it. But just know that if they ever talk about an inconsistent system, they are talking about a system that has no solution. If you are inconsistent, that means you have no solution. Just in case you see that somewhere. Okay? All right, so here we go. This is how we're going to solve a system today. We're going to solve it by graphing. So you have to follow these steps. To solve a system by graphing, number one, we need y equals mx plus b. So we're going to solve each equation for y. Sometimes it's already done for us, so you got to love that. Right? Think y equals mx plus b form if we're going to graph. All right, once you solve each equation for y, go ahead, graph them if you need to. Now again, the only reason I put if needed, I'm just going to give you guys a hint. If the system ends up being no solution or IMS, you should not need the graph to know that. You should be able to tell that just by looking at the equations, and I'll show you what I mean. Because guys, do we really want a graph if we don't have to? No. All right, and then the third thing is you have to find that point of intersection. What point do these lines meet at? What's the x and y value that makes these equations true? Okay, let's do a problem. My mask is itchy today. Because I washed it or something. All right, here we go. Here we go. All right, so guys, whoa, what did I do? I went way too far. Oh, I forgot. I split the page in half. Confused myself. All right, guys, sorry. Example 1's at the top here. I split this page in half. All right, so example 1. If we have to solve this system by graphing, first thing we want to do is solve each equation for y. You got to love it. The first one, he's good to go, baby. He is already in y equals mx plus b form. But guys, I'm not going to graph it. I don't think you should graph until both equations are solved for y. So you can compare the equations, because maybe you won't need to graph to get the answer. All right, so to get this one, let's add x to the other side, and you end up with y equals x plus 4. Okay, so guys, if you look at the two equations, they are clearly not the same equation. So they are definitely not the same line. So they're not going to have infinitely many solutions. So we can rule that right out. All right, they are definitely not parallel lines. This one has a slope of -1. This one has a slope of +1. They don't have the same slope. So these are not parallel lines. These are lines that are definitely going to meet. So let's graph them and see where they meet. All right, so I'm going to graph, doesn't matter which one. I'm going to graph the top one first. So I'm going to go to my y-intercept of 2. And then my slope is -1/1. So down 1, right 1. Down 1, right 1. I give myself lots of dots for the other line to connect at. And then instead of going down 1, right 1, I'm going to go up 1 and left 1 a few times, just to give myself lots of dots for the other line to meet it at. All right, so guys, right now, what you've just done, every single x and y value on this line are the x and y values that make the top equation true. But I don't want the x and y values that just make the top equation true. I want the x and y value that make both of these equations true. So now let's graph this line, see what points make him true, and then we'll find the one where they meet at, the one point they have in common, the one point that will make both equations true. All right, so I'm going to go up 4, and then this one has a slope of 1 over 1, so I'm going to go up 1, right 1, up 1, right 1. But guys, you're going the wrong way. The other line is behind it, so don't go that way, go the other way. So go down 1 and left 1, and you actually come immediately to an intersection point. So now all of these points make the bottom equation true. But that one point right there where they meet at, that's the solution to this system. That's the 1x and the 1y value that will make both of these equations true. So guys, the graph is not our answer. That point right there is our answer. So does anybody know what ordered pair that is? Left 1 and up 3. Anybody know?
Negative 1/3.
Yeah, negative 1 and 3.
Oh, wait, and 3, yeah.
I know what you meant. So the point is negative 1, 3. So guys, that's the answer. That's the x and y value that make these equations true. It's not the graph. So on Delta Math tonight, they're going to give you a graph. They're going to graph a line. They're going to graph another one. Then you have to find that intersection point, and this is what you type in the answer box, the ordered pair that they meet at. All right? Thank you, Fatima. It's okay. All right, so now, if you're looking here, watch this. This is what we're talking about. If I plug this in for y, 3, and this in for x, negative 1, it turns to plus. 3 equals 3. He makes that equation true. If I plug it in here, 3 equals negative 1 plus 4. 3 equals 3. You have literally found an x and a y value that make both of these equations true. That's the point. All right, let's try another one.
You got a terrible spot.
All right, here we go. First things first. Guys, we're going to be solving for y like crazy. There should be no equation that we cannot solve for y at this point. All right, so to get y by itself, all we have to do is minus the 2x to the other side. So then I get y equals negative 2x plus 3. Again, I don't think you should graph yet. I do not graph until I've solved both equations. All right, in this one, I'm going to add x and minus 4 to the other side in one step. That leaves me with 2y's equal. There's no x's to add x to on that side, so he'll just stay x. And then 0 minus 4 is negative 4. And then I'll divide everything by 2. Doesn't divide or reduce. And then minus 2. All right, so guys, look. Clearly, these are not the same line. So they're not going to have every single point in common. We're not going to get IMS. Also, this one has a slope of 1/2. This one has a slope of negative 2. They ain't parallel lines either. These are lines that are going to meet. They're going to have an intersection point, and we got to find it. So let's graph them. All right, if I graph this one, doesn't matter which one. I'm going to go up 3, and then negative 2 over 1. Down 2, right 1. Down 2, right 1. Or up 2 and left 1. Just do it a couple times. Give yourself lots of points for the other graph to meet. All right, let's graph the other line. The other line has a y-intercept of negative 2 and a slope of 1/2. So up 1 and right 2. And actually, when you go up 1 and right 2, you come immediately to an intersection point. So again, it's not the graph that is our answer. It's that point right there. So right 2 and down 1, that's the point. 2, negative 1. That is the solution to your system. That is the x and y value that will make both equations true. Are you guys okay? Everybody's good here? At home, are we okay? Thumbs up, we're all right? I'm going to try and do 2 more with you to show you 2 other scenarios, and then we should be good to go. this one. We gotta solve this by graphing, right? So guys, we're in algebra 2 now. They're gonna give us all kinds of things that we have to do to get y by itself, but we're fine. We're gonna distribute the -2. We're gonna get 5y minus 2x minus 2y equals 15. I got like terms. 5y take away 2y is 3y minus 2x equals 15. I'm going to add my 2x's over, start getting y by itself. And then the only thing I got left to do is divide by 3. Two over 3 does not divide or reduce. So we are good to go there. Again, I would not graph it. I would wait. I would solve the other one for y. So if I want to solve this one for y, it's a little bit easier. I'm going to minus my 2x's. I'm going to get negative 3y equals negative 2x plus 12. And then divide everything by negative 3. Again, I'm only doing this quickly because I'm assuming we're all okay. All right, and then y ends up equaling a negative over a negative is positive. 2 over 3 does not divide or reduce. And then 12 divided by negative 3 is minus 4. All right, so guys, let's compare. Because if I don't have to graph, I don't want to graph. Look at it. They're clearly not the same line. So IMS is definitely not the answer. Not going to have every single point in common. But guys, they have different y-intercepts, which means they're different lines. But they have the same slope. So if they have the same slope, they are parallel lines. Parallel lines never meet. If they're never going to meet, are they going to have a point of intersection and an x and a y value? No. So if these are parallel lines, that means the answer has to be no solution. And again, the reason the answer is no solution is because they're parallel lines. So I'm trying to save you guys from having to graph, right? But if you graphed, it just would have been this, right? You would have gotten this line, and then you would have gotten this line. So you still would have seen, oh, wait a minute, those lines never meet, they're parallel. I'm just trying to save you from having to put that graph out there. Because if you don't have to graph, I don't want you guys to graph, all right? But the answer is definitely no solution. All right, let's see if we can do example 4, and then that should be good for today. Okay, first we're going to solve for y. I know, I'm so sick of it. I am too. All right, so we solve for y. All right, I'm going to minus my 2x's. I get negative 3y equals negative 2x plus 9. And then divide everything by negative 3. Right, negative over a negative is now positive. 2 over 3 does not divide or reduce. And then minus 3. So there's one line. Again, I wouldn't graph it until I compared it to the other line. Guys, we come over here. A couple different things you could do. We know how to get rid of fractions. If you don't want to work with fractions, then go to your bottom number, 2, 3, and 2, and find me the smallest number that a 2 and a 3 and a 2 can all become through multiplication. 6. Times your tops by 6, and the fractions will literally disappear. So 6 times y is 6y, divided by 2 is 3y. No more fraction. All right, 6 times x is 6x, divided by 3 is 2x. No more fraction. Bring down the minus sign so I don't lose it. 6 times 3 is 18. 18 divided by 2 is 9. And now all you have to do to get rid of y, to get y by itself, is divide by 3. Two over 3 does not divide or reduce, and then minus 3. So guys, when you look at these ones, like, oh, are they parallel? Well, guys, this time, yes, they have the same slope, but they also have the exact same y-intercept. So they actually represent the exact same line. So if you were to graph this line, you would end up graphing this one right on top of it because they're the exact same line. They have every single point in common, which means every single x and y value on his line makes his equation true as well. So this means there's so many answers, I couldn't list them all. So this is when we end up with infinitely many solutions. And again, the reason that is because they end up being the exact same line. All right, so if I was to graph this one, I would get this line. When I go to graph this line, I would literally be graphing the exact same line. I'd be graphing it right on top of it. They have every single point in common. Okay? Do you guys remember this from Algebra 1? Does this ring a bell? Okay. All right, so guys, everybody at home, do you feel okay? Yes?